Hi, hello, good evening, one and all. Now, let's get started in our JEE mains preparation. Now, what is JEE? First, before preparing for JEE mains, let us know the basics about the examination and the rules of the JEE mains examination. Joint entrance examination conducted by National Testing Agency. So, JEE has two examinations, and the first one is JEE mains and second one is JEE advanced. The candidates who are eligible for JEE mains are +2 completed students. Now the candidates who have qualified in JEE mains are eligible to write JEE advanced. In each subject, that is from maths, physics, chemistry, we have 25 questions, of which 20 questions are multiple choice and 5 questions are numerical. Now, in our preparation, let's solve a mock paper for JEE Mains Maths. It is also useful for your state board examinations and also for EAMCET examinations. Now, welcome to my channel. Now we will start the mock paper. The first question in the mathematics section is as follows. If the roots of the equation, it's a quadratic equation given here, ax square plus bx plus c is equals to 0 are in the ratio m is to n. Then this is also a standard result which comes in quadratic equations chapter. It is very useful. So now let's see the solution. Here it is given that the roots of the equation are in the ratio m is to n. Now we can assume each part in the ratio is x. So now the roots will be mx and nx. Now if we take a polynomial ax square plus bx plus c, it's a quadratic polynomial. The sum of the roots in this polynomial is minus coefficient of second term by coefficient of first term. That is, here the second term is x coefficient, the first term is x square coefficient. So sum of the roots is m plus n into x. As we said earlier that the roots are mx and nx. So as per the formula, sum of the roots is equals to minus b by a and product of roots is equals to m and x square is equals to last term by coefficient of first term. That is, in quadratic equations, product of roots is equals to c by a. Now from first and second statements we get x is equals to minus b by a into m plus n, and substituting the value of x in second statement, that is m and x square is equals to c by a, we get mn into minus b by a into m plus n whole square is equals to c by a. This implies mn into b square is equals to c by a into a square into m plus n whole square. This gives mn b square is equals to ac into m plus n whole square. That is, the option is A. I hope you understand. Let's roll to second question. The domain of definition of the function y is equals to 3 into e power of root over x square minus 1 log of x minus 1. The options are A, 1, open 1 comma infinity, and option B is closed 1 comma infinity, and option C is r minus 1, and option D is minus infinity comma minus 1 open union open 1 comma infinity. So before starting this question, we should know some basic conditions that while we are writing a real root, the quantity that lies in the real root should be a zero or positive quantity, and also we should take only positive quantities while defining a logarithmic function. So while starting the question, Here we have taken the given function y is equals to 3 into e power of root over x square minus 1 log of x minus 1. As we have discussed earlier, x square minus 1 is under root. So, it should be greater than or equals to 0 because it is under root. So, now transposing 1 to right hand side, that is transferring 1 to RHS, we get x square is greater than 1. Now, the interval in which this satisfies is x belongs to minus infinity comma minus 1 closed union closed 1 comma infinity. Why? Because the terms minus 1 and 1 satisfies the equation. Also, x minus 1 is given in a logarithmic function. So, x minus 1 should be positive. Why? Because we have discussed earlier that only positive quantity should be in logarithmic function. So, x minus 1 is greater than 0. So, x is greater than 1. Now, the interval is x belongs to open 1 comma infinity. Why? Because if we put 1 in the expression x minus 1, it is equals to 0 but not greater than 0. So, when we take a number line method, if we plot the terms, the digits minus infinity, minus 1, 1 and infinity on the number line, we can see the common region is open 1 comma infinity. So, the common region is open 1 comma infinity, that is in the region open 1 comma infinity, the whole function y is equals to 3 into e to the power of root over x square minus 1 log of x minus 1 is defined. So, it is the domain. Okay, understood? Now, let's get started and let's move to the third question, which is from definite integrals. Please see the question. As the question asks, the integral minus 1 to 1 x minus step x. Here this step x is greatest integer function. So the options are A 0, B 1, C 2, D none. Before seeing the answer, I suggest you to please pause the video and try yourself and then watch the solution, because if we try like that, you can get your own ideas. So if now while seeing the solution, here we are considering step x is greatest integer function. It is greatest integer function. Now let's move on to the question. Integral minus 1 to 1 x minus greatest integer function of x into dx. Now it is following a formula integral a to b f of x minus z of x dx. Here two functions are given. The first function that we are considering f of x, it is x, and the second function is greatest integer function of x. So it is in the form integral a to b f of x minus z of x dx. This is equals to integral a to b f of x dx minus integral a to b g of x dx. Now we are splitting that term integral minus 1 to 1 x minus step x dx into two terms. I hope you understood. Now while writing integral minus 1 to 1 x dx, we have a formula in integration which suggests integral x power n dx is equals to x power n plus 1 by n plus 1 plus c. So we are writing the integration product based on the formula. We get x square by 2 limits minus 1 to 1 minus integral of minus 1 to 1 step x dx. While before writing the answer for integral minus 1 to 1 fraction greatest integer function of x, we should you should keep in your mind about greatest integer function. What is a greatest integer function? Now Here we are given the limits minus 1 to 1. Now if you see the behavior of greatest integer function in the limits minus 1 to 1 from 0 to minus 1. 0 to minus 1, that means when x is less than 0 and greater than or equals to minus 1, in this case step x is equals to minus 1. That is greatest integer function is equals to minus 1, and when it is 0 less than or equals to x less than 1, that means the step x value, that is greatest integer function value, is equals to 0. Now splitting the greatest integer function from the limits minus 1 to 1 step x dx to minus 1 to 0 step greatest integer function of x dx plus integral of 0 to 1 greatest integer function of x dx. Okay, on substituting the value of step x in the both of the respective conditions, we get the answer. And earlier we have here x square by 2 limits minus 1 to 1. What is the answer? 1 by 2 minus of minus 1 by 2 whole square by 2 minus of 1 by 2 whole square by 2. So I have written here shortcut method. Okay, now here comes the answer. The final answer is plus 1, which is option B. Now please give a like who have made the correct answer and who have ticked the correct answer B. Okay. Now let's start the fourth question. Let us take a flag here, a flag staff which is of height 5 meters. It is standing on a 25 meters high building. Maybe it's August 15th. Okay, now another observer who is very leisure, he is observing this flag staff. So he is at a height of 30 meters and it is subtending equal angles, the flag staff and building. Now we should find the distance of the observer from the top of the flag staff. The options are as follows. Now let's move to the solution. Now imagine the situation and first draw it. It is the question from application of trigonometry, and drawing of the situation will give you a clear cut image of how to solve the problem, how to approach the problem. Here we have given the equal angle. Here in the figure I have marked them with alphabets. BC is the flag, AB is the building, ED is the observer. From the building, triangle BCD, tan alpha is equals to 5 by x. From triangle ACD, tan 2 alpha is equals to 30 by x. Now applying the formula tan 2 alpha is equals to 2 tan alpha by 1 minus tan square alpha, which comes in trigonometry as you all know well. Now 30 by x is equals to 2 into 5 by x by 1 minus 25 by x square. This implies 3 by x is equals to 1 by 1 minus 25 by x square. Solving this equation, we will get that x is equals to 5 into root over 3 by 2 meters. Now the correct option is A for, okay, let's take A for apple. Now let's move on to the fifth question. The fifth question says, if r is equals to set bracket of x comma y such that x comma y belongs to z, that means integers, x square plus y square is less than or equals to 4, is a relation in z. Okay, here he given a relation. Now he is asking us to find the domain. The options are as follows. Now before finding the domain to the given respective function, we should think of the given conditions. X square plus y square is less than or equals to 4. That means if you put 2 as one of the terms x or y, The other term should be 0 because the term should be less than or equals to 0. So whether it may be plus 2 or minus 2 as the product, as the terms are in even power. So if you take minus 2, the next one is 0, and if the eligible uh, the eligible coordinates are here as given. Now from this we can see the eligible coordinates. Now from this we can write the domain of R as 2. Here we have taken minus 1 and 0, 1 and 2. That's all. Because we can't take 3, because if we take 3 as one of that in x or y, we will get 9. So it is not less than or equals to 4. So the option is C. C for chocolate. Yeah. How many of you like chocolate? Please comment. Now if 5 power 97 is divided by 52, the remainder. He is asking about the remainder. We can do this in many ways. Now okay, let's do this in binomial theorem method. The options are here as given. Now 5 power 97 can be written as 5 power 96 into 5. 5 power 96 can be written as 5 power 4 into 24. We all know very clearly that 5 power 4 is equals to 625, which is equals to 52 into 12 plus 1. Why have we have used 52? Because he asked us to divide with 52, and we will write the number 5 power 97 in terms of 52, and then it will be easy for us to write the answer. Now okay, 5 power 4 is equals to 52 into 12. Let us take lambda, 52 lambda plus 1. Now 5 power 96 is equals to 5 power 4 whole power 24. Now applying whole power to the both sides of this expression, 5 power 4 whole power 24 is equals to 52 lambda plus 1 whole power 24. Yeah. 5 power 96 is equals to 52 lambda plus 1 whole power 24. By binomial expansion, we can write it as 24C0 52 lambda whole power 24 plus 24C1 52 lambda whole power 23 and plus and so on 24C24. Now taking 52 as common from this expression, we will get 52 into 24C0 52 whole to the power of 23 into lambda power 24 plus 24C1 52 to the power of 22 lambda power of 23 and plus and so on to 24C23 lambda plus 1. Okay, now we have right 52 lambda plus 1 whole power 24 is equals to a multiple of 52 plus 1. Why have we have written a multiple of 52? Because we have already taken 52 as the common factor from all these terms. So when you divide this with 52, we will get the remainder as 1. Now we have actually want 5 power 97, but here we have used 5 power 96 instead. So multiplying both sides with 5 for this equation, we will get 5 power 97 is equals to 5 into multiple of 52 plus 5. So the remainder is 5. The option is B for Bombay. You can also say it as a banana, ball, or your wish. Now the seventh question is, if y is equals to 4x minus 5 is a tangent to the given curve, y is equals to px cube plus q at a point 2, 3, then what are p and q? It's a good question. Okay, now let's start doing this question. Here it is given that y is equals to 4x minus 5 is a tangent to the curve y square is equals to px cube plus q at 2, 3. Now differentiating the curve with respect to curve with respect to x, we get y square is equals to px cube plus q. Differentiating, we get 2y dy by dx is equals to 3x square into p, and q is a constant, and differentiation of a constant term v is equals to 0. So dy by dx is equals to 3x square p by 2y. Now we already know to calculate the slope at a point. So while calculating the slope, we get the answer as slope is equals to 2p. But already we are given y is equals to 4x minus 5 is a tangent of the curve. So that for what is the form of the tangent? Y is equals to mx plus c. From this form we can get slope m is equals to 4 and p is equals to 2, as 2p is the slope. As the curve is passing through the point p comma q, substituting the 2 comma 3, substituting the value of p in the curve, we get q as minus 7. Now p comma q is equals to 2 comma minus 7. Now let's move on to the 8th question. The number of discontinuity of f of x is equals to greatest integer function. Greatest integer function. Earlier we have discussed about this function. Now again we are looking into the condition of the greatest integer function. It is discontinuous on integral values. Here we are given the domain of, that is the range of the domain of x. X belongs to minus 7 by 2 comma 100. Now simply we should look at the number of integers from minus 3.5 to 100. Okay, we have written that the total number of integers are 103, starting from minus 3 to ending up to 99. Total number of integers are 103. 9th question. The number of ways of selecting 15 teams from 15 men and 15 women such that each team has a man and woman. Now, the answer, while answering for this question, we should remember that we have given each team should have at least a man and a woman. At least a man and a woman. That means we are taking, while considering the first team, we will have 15 members, 15 men and 15 women. That means 30 members. One man and one woman is selected. So the remaining are 14 men and 14 women. One is selected. So the remaining are 13 men and 13 women. In this way, if we are selecting everyone for a team, finally we will get the total number of ways of selection. That is 15 into 13 into 12 and so on we will get, that is 15 factorial is the answer. Y is equals to x minus 1 whole square, comma y is equals to x plus 1 whole square, and y is equals to 1 by 4. A 1 by 3 square unit, B 2 by 3, C 1 by 4, and D 1 by 5. Y is equals to so here y is equals to now plotting the curves, y is equals to x minus 1 whole square and x plus 1 whole square and y is equals to 1 by 4 on the graph sheet. You can observe there is a common portion, that is a triangle, which is symmetrical on both sides on the number line. Yes, we have got it. Now when the curve, the reason to find the area is of this type, we can write 2 into integral 0 to 1 by 2 x minus 1 whole square minus 1 by 4 dx. This is a common method of to find areas in the chapter, and solving this by applying limits and doing a small integration, which is integral x power n dx, as we have discussed earlier, we will get the answer as 1 by 3 square unit. The option is A for apple. Now the 14th question is as follows. Number of roots of the equation cos square x plus root 3 plus 1 by 2 sin x minus root 3 by 4 minus 1 is equals to 0 lie in the interval minus pi comma pi. A 2, B 4, C 6, D 8. Now the basic formula of trigonometry, we are applying this formula. What's that? Cos square x plus sin square x is equals to 1. So applying this formula we get 1 and 1 minus sin square x, and this 1 is get cancelled. You can see here, you can see on the screen. Okay, sin square x minus root 3 plus 1 by 2 sin x plus root 3 by 4 is equals to 0. Now we are multiplying whole the term with 4. Okay, and we have the expression 4 sin square x minus 2 root 3 sin x minus 2 sin x plus root 3 is equals to 0. Now taking the term 2 sin x from the first two terms as common and also minus 1 from the last two terms as common factor, we get the factors as 2 sin x minus root 3 and 2 sin x minus 1 is equals to 0. On solving we get sin x is equals to 1 by 2 comma root 3 by 2. Therefore the possible values of x are as follows: pi by 6, 5 pi by 6, pi by 3, 2 pi by 3. So the possible values of 4, the option is B. 15th question, we are asked here, if x is equals to 33 whole to the power of n and n is 33 power of n or 33 power of n is a positive integral value, then the probability that x will have 3 at its units place. Now guys, please remember we are asking here 33 power n, where n is a positive integral value. Now if n is a positive integral value, we have the possible digits in the units place are 3, 9, 7 and 1. These will repeat na. So okay, we have 4 possible cases. What are they? 1, 3, 7, 9 at units place. What is our favorable event? Our favorable event is to get 3 at the units place. So what is the formula for finding the probability? Number of favorable events by total number of events in the sample space, that is 1 by 4. Option is B. Here okay, we are asked a question. The question is so the question is as follows. The question is as follows. Okay, please wait for a while. Please wait for a second. Okay, it's a while. PDF. Question. Okay, the question is A, B, C, D and E, F are in AP. And also please wait. A, B, C, D, E, F are in AP, and we are asked to find out something here. Okay, while taking these the terms, we get that we are considering the common difference is equals to P. Now B is equals to A plus B and C is equals to B plus P, and this is a trend of arithmetic progression series. Now we are asked to calculate what is the term E minus C. It's a very easy question from a basic knowledge. We already know that E is the fifth term, so E can be written as A plus 4P, and C is the third term, it can be written as A plus 2B. Subtracting these two terms from each, we get the value as 2P, where P is the common difference between each two terms, that means D minus C, which is the second option. Now let's move to another question, which is from integrals. NTA has stressed the calculus part here in this mock paper. Okay, let's see the next mock paper how they will give. Now integral of ln. What is ln? Log to the base e, natural logarithm. Ln x plus 1 minus ln x by x into x plus 1 dx. Here, if you clearly observe one thing, you will get that if you take ln x plus 1 minus ln x as a term, let us take the term as z. Now differentiate this term. 1 by x plus 1 minus 1 by x is equals to dz by dx. Now x minus of x plus 1 by x into x plus 1 is equals to dz by dx is equals to minus 1 by x into x plus 1 is equals to dz by dx. Now dz by dx is equals to minus 1 by x into x plus 1, which is here in the question. Now the question, we have formulated the question into integral minus z by minus z dz, which is z square by minus z square by 2 plus c. The option is A, minus 1 by 2 ln x plus 1 by x whole square by plus c. The 20th question is as follows. Okay, this question is from functions, and this is a special topic, I think, from functions. Now this is called as functional equations, and these functional equations, we can remember them, and mostly questions are being asked from this topic. This is an important topic. Okay, now here the asked functional equation is f of x into f of 1 by x is equals to f of x plus f of 1 by x. And also he have given that f of 2 is greater than 1, and he asked us to find out limit of x tends to 1 f of x. Now the solution is, we have directly the formula for this case of functional equation. We can consider f of x is equals to 1 plus or minus x power. Okay, now if we want to derive the method how we got f of x is equals to 1 plus or minus x power n, here we have derived for you. Okay, now let's focus on this for a while. F of x into f of 1 by x is equals to f of x plus f of 1 by x. That is the given functional equation. Now taking f of x and f of 1 by x to left hand side and adding 1 on both sides, we get this form. And if you reduce that into factors, that is f of x minus 1 into f of 1 by x minus 1 is equals to 1. Understood? Understood, students? Understood, friends? Understood, my dear guys? Okay. Now taking h of x as f of x minus 1 and h of 1 by x as f of 1 by x minus 1, and we get, as f of x is a polynomial, h of x is also a polynomial. Therefore h of x is equals to plus or minus x power n is a polynomial of nth degree. F of x is equals to plus or minus x power n plus 1. We have already given that f of 2 is greater than 1, so f of x is equals to 1 plus x power n. Now applying the limit to the function f of x, limit x tends to 1 f of x is equals to limit x tends to 1 x power n plus 1 is equals to 2. Okay, we have got the required answer. Okay, remember from the question 20th itself, here he is asking us numericals. Now the 21st question, it's a very good question from matrices, and you can solve it in two methods. Here he have given a matrix, a 3 by 3 square matrix. A is equals to 1 0 0 0 0 1 0 0 2 minus 2 4, and also given a unit matrix. And now to find out A inverse is equals to 1 by 6 into A square plus CA plus D. Now he have asked us to find C plus d, the sum of values of c plus d. Now in method 1 we are given taking the given statement a inverse is equals to 1 by 6 into a square plus ca plus d, and finding out a square and a cube from the given matrix, and simply doing a into a inverse is equals to I is equals to 1 by 6 into a cube plus ca square plus da, and comparing the terms we get you the answer c and d. C and D has minus 6 and 11, and this is the general method. And there is another method, that is finding out by writing the characteristic equation, that is a minus det of a minus lambda I is equals to 0, and where lambda here we can get the eigenvalue, and while doing this we get det of, we have got the characteristic equation is, that is det of a minus lambda I is lambda cube minus 6 lambda square plus 11 lambda minus 6 is equals to 0. And here now we are using a theorem called Cayley-Hamilton theorem. We will discuss about this theorem later after finishing this problem. A cube minus 6a square plus 11a minus 6i is equals to 0. Now multiplying a inverse on both sides, we get this expression. Now a inverse is equals to 1 by 6 into a square plus 6a plus d. Comparing, we get c is equals to minus 6 and d is equals to 11. Now c plus d is equals to 5. Now discuss what is Cayley-Hamilton theorem. Okay, in a linear algebra, the Cayley-Hamilton theorem states that every square matrix, you can take any square matrix, any square matrix satisfies this theorem, and every square matrix or a commutative ring satisfies its own characteristic equation. What is he saying? Satisfies its own characteristic equation, that is det of a minus lambda is equals to 0. 0. Now we have applied the same here, that is the characteristic equation is lambda cube minus 6 lambda square plus 11 lambda plus 6 is equals to 0. We have, by using Cayley-Hamilton theorem, we have replaced lambda with a. That means the matrix, the square matrix, is satisfies its characteristic equation. It's a very good theorem. You can directly write the answer by using this theorem. Okay, now let's move on to the next question. We are asked to find the least value of the quadratic polynomial fx is equals to 2p square plus 1 x square plus 2 into 4p square minus 1 into x plus 4 into 2p square plus 1. Rearranging the terms, we get 2p square into x plus 2 whole square plus x minus 1 whole square plus 3. You can see this. He asked us for the minimum, the least value. For y being the least, we should, if we take p as 0, we can, one term will be removed, and if you put x as 1, and the term will be removed. That means the minimum value of this function is 3. Okay, this is the answer. If we move to the next question, it is given that a, b, c are an arithmetic progression. Okay, it's good. A, b, c are an arithmetic progression. The angles a, b, c are an arithmetic progression, and given that angle b is 45 degrees, pi by 4. Then he asked us to find the product of tan a into tan b into tan c. Solution: angles a, b, c are in AP, and angle b is pi by 4. Okay, it's good. Now as they are in AP, differ by a common difference in the angle, theta angle. A is equals to 45 minus theta, and b is 45, c is 45 plus theta. Now multiplying these three tangents, tan angles, that is tan a into tan b into tan c, that is tan of pi by 4 minus theta, tan of pi by 4, tan of pi by 4 plus theta. We already know that tan of pi by 4 is equals to 1. So the answer is also tan of pi by 4 minus theta From the formula tan of a minus b and tan of a plus b we deduce here. These are the basic formulas in trigonometry which you will learn in the chapter trigonometry of mathematics. Okay, tan a minus tan b and tan a plus tan b and tan of a plus b. Sorry. Tan of a minus b formula you will learn. Okay. Little bit confused. No. The problem number 24. The distance of the point minus 1 comma 1 from the line 12 into x plus 6 is equals to 5 into y minus 2 is. The given line is 12 into x plus 6 is equals to 5 into y minus 2. And writing all the terms on the left hand side we get the line, and the perpendicular distance from the point minus 1 comma 1 to the line, writing the perpendicular distance we get it as 5. Okay, it's the answer. Now it's time for the last question. Okay, what's the last question? Suppose that the side lengths of a triangle are 3 consecutive integers. These are the side lengths are 3 consecutive integers, and one of the angle is twice the another, and one angle in the triangle is twice the another. Then number of such triangles possible. Again, pause the video and try it your own, do it yourself, and comment it in the chat box. The first 5 members to comment in the chat box will be named in my upcoming video. Okay, I am giving you a small hint for this. You can use cosine rule for getting this answer easily. Okay, thank you for watching. Please like, share and subscribe my channel if you really love the content. Okay, it's time for us to take a bye. Thank you for watching. We will meet again soon. Please like, share and subscribe because it's free.